Hey folks, so this is a video over ellipses, section 10.2, and the intent here is to do two different videos. So, and I am going to skip around a little bit. So I'm going to, in the first video, I'm going to do example 1 and example 3. But first, let's go ahead and introduce to you what an ellipse is. So the first thing that you notice here is that it has its center at HK. And it's either going to be a horizontal or a vertical ellipse, and that all depends on the major axis. So before I get anywhere further than this, let me just zoom in. You'll notice that this is a horizontal ellipse because it is elongated along the horizontal, whereas this one is more vertical. The major axis is the that axis of symmetry that goes along that long axis of symmetry. I'm sorry, that's rather redundant, but it's that axis that cuts the ellipse in half the long way. So in this one, my axis of symmetry, that major axis, is going to be a vertical axis. So just understand the major axis is the axis that splits it in half the long way. Another way to see this is to start naming some different pieces of my ellipse. The ends of the major axis, these right here, these are called vertices. So every ellipse has two vertices. That's the plural form of vertex. And so you could also say that the major axis goes from vertex to vertex. Our vertices are always going to be, well, I'll say that in a minute. The next thing that you have is you've got the minor axis. And so the minor axis is going to stretch. It's going to be the axis of symmetry that cuts the ellipse the short way. Okay, so this here, this is my minor axis. The ends of the minor axis, this is going to blow your mind. These are called the ends of the minor axis. We don't have a special name for those. So this is the end of the minor axis. And then one last pair of points that are going to be important. You've got a pair of foci, plural for focus. There are two focus points. And if you were to only look at this part of my ellipse, let's see, I've muddied that up a little bit, so let me come down here and do it this way. If you look at just this piece of your ellipse, this kind of looks like a parabola, and we know that inside the parabola we have a focus. So it's a very similar situation as what we had in the last section with parabolas. Now, I want you to notice that my two equations are very, very, very similar. Notice that the numerators are identical. It's the denominators that are different. So let's define what A, B, and C are, and that's going to be down here. So distance A is always going to be the distance from the center to the vertex. So this picture is clean. If I go from the center to the vertex, this is going to be the distance of A. The distance of B is going to be from the center to the end of the minor axis. And the distance of C is going to be from the center to the focus. Now, another way to say those things is that the vertices are always A away from the center. The ends of the minor axis are always B away from the center. And lastly, the foci are always C away from the center. So those, basically, these three statements and these three statements are the same thing. It's just a different verbiage, a different way to say the same thing. All right, so coming back then, since A is always tied to my major axis because it goes to the vertex, that means A always, always, always has to be the longer value. So as I go back to my equations then, here the larger denominator is under the x's. When the larger denominator is under the x's, I have a horizontal axis of symmetry, or a horizontal major axis. On the next one, notice that my larger denominator, because A is associated with the vertex, which is associated with the major axis. So my A's here are, the larger denominator is under the Y's. So when it's under the Y's, notice that my ellipse is going to be up and down. It's going to be vertical. Last but not least, if you have to work with the foci, then you're going to want this tiny little equation. This equation is c squared equals a squared minus b squared. It's not going to be a negative number because this a squared is always going to be a larger number than the b squared. When I'm in class, I call this guy little dude. So I guess that I will probably slip up on the video and call it little dude as well. All right, so when you are graphing ellipses, this is just a repeat, I've already said this, but when you are graphing ellipses, remember that the location of a squared, which is the greater denominator, is going to determine whether the ellipse is horizontal or vertical. The other thing too is that when you use that little dude, that c squared equals a squared minus b squared, remember that your a squared has to go first because a is greater than b. All right, so let's go ahead and work on example number 1. Example number 1 says that we should graph, we should find the coordinates of the foci, and then we should also give the domain and the range. So I'm going to focus in here on part A. The problem with part A is that it's not in standard form. Let's go back to that standard form. Standard form says I have to have an equals 1 on the right-hand side. So since I don't have that, that's going to be the first thing that I need to work with. And so getting it into standard form says that we're going to divide all 3 terms by 100, and then I'll reduce each of my fractions. And when I reduce my fractions, I'll get x squared over 25 plus y squared over 4 is equal to 1. Now immediately I can tell that since my larger denominator is under the x's, this is going to be a horizontal ellipse. I know it's going to be one of these guys. Okay, so it will be a horizontal ellipse. My a value is going, let's see, I don't even remember the order that I hid these things, so let's see what's underneath. We can see that the center is at 0, 0, so let's go ahead and put that on our graph. The center is at 0, 0. And the next thing is that my a value is 5. Again, my a is always going to come from the larger denominator. Since my larger denominator is a squared, then I know that my a value is 5. And since this is a horizontal ellipse, that means that I'm going to go 5 to the right and 5 to the left to be able to get to the ends of my minor axis, or to get my vertices. All right, my b value is going to come from my smaller denominator. My smaller denominator is 4, which is b squared. So my b value is 2. And this tells me that the ends of the minor axis are going to be up 2 and down 2. Now, I have enough information now to go ahead and graph. So you can just connect the dots. Now let's go find the foci. In order to work on the foci, in order to work with the foci, I need to use little dude. So my formula there is c squared equals a squared minus b squared, which is going to be 25 minus 4, which is 21. So my c value, the distance to each focus point, is going to be the square root of 21. The focus is going to be on the major axis, so my focus is going to be found to the right and to the left. And so remember, this is going to be c away from the center. So then my 2 focus points are going to be at positive or negative square root of 21, comma 0. So root 21, 0 and negative root 21, 0. Now, before I get any further, there's one thing that I didn't say when I was introducing the ellipses, And I want you to notice that on the major axis, I have 5 major values. So let's take a look at what those 5 major values are. First of all, I have the center, and then I have 2 foci, and I have 2 vertices, for a total of 5 major values on the major axis. So on this guy here, this is how I knew that the focus, the 2 focus points were going to be found to the right and to the left. All right, the last thing that I was asked for is my domain and range. So my domain will go from -5 to 5, and my range will go from -2 to 2. All right, let's go over to part B and do the same thing. Again, the first thing that I want to work on is to get my ellipse in the standard equation. So I'm going to divide all 3 terms by 441. When I reduce my fractions, I'll get x squared over 9 plus y squared over 49 is equal to 1. Immediately, I see that the larger denominator is under the y's. So this particular ellipse is going to be vertical. My center, once again, is going to be at 0, 0. My a value is going to be 7. Again, that a value comes from the larger denominator. That's my a squared. And my b value is going to be 3. I can use little dude then to find my c value. So c squared will be a squared minus b squared. That's going to be 40. So c will be 2 root 10 once I simplify that square root. So this is going to help me to know where my foci are. So now I do have enough information to graph, so let's go ahead to the graph. My a value says that we're going to go up and down 7 from the center, and the center's at 0, 0. My b value says that I'm going to go right and left 3. So then this is enough to go ahead and graph. All right, so then let's go ahead and get our focus points. So we're going to use that c value. This time my focus is going to be up and down from the center. So that's going to be at 0, positive 2 root 10, and 0, negative 2 root 10. My domain goes from -3 to 3, and my range goes from -7 to 7. All right, so what I want you to do next is I want you to skip over example number 2, and we're going to go down to example number 3. So this is a very similar question. The first thing that I want to point out is that I changed the question. So if you printed your notes and you're filling in your notes, you'll notice that I switched the denominators. I traded the denominators here. Okay, so the first thing that I can see is that my center is going to occur at 3, 0, because this is my H is 3 and my K is 0. So my center is at 3, 0. So we can go ahead then and draw 3, 0. My A value and my B value, well, my A value is 6, my B value is 3. Since my larger denominator is under the y's, this guy is going to be a vertical ellipse. And so we can go ahead and draw our ellipse. So from the center, we're going to go up 6 and down 6. And from the center, we'll go right and left 3. All right, in order to find my foci, I need to use little dude. So this is going to be c squared equals a squared minus b squared. Once I simplify my square root, that's going to be 3 root 3. So on this one, I'm going to take just a little bit more time. My foci are going to be up and down from my center. Okay, so my center is at 3, 0. And my 3 value, my x value, is not going to change because I'm going to go up and down. It's my y value that is going to change. So from my center then, my foci, the 3, the x value isn't going to change, but I'm going to go up 3 root 3 or down 3 root 3 from that center point. So that gives me my focus. my 2 focus points. Domain is from 0 to 6, and my range is from -6 to +6. The reflection question here, I'd like for you to really think about this one. If A is equal to B in the equation of the ellipse, what does the graph look like? So I want you to even just look at it with this question. If both of my denominators were 9, then this would mean my A value is 3, my B value is 3. But what does that do to my graph? How does that change things in my graph? Hopefully you said that your graph is going to be a circle. Really, guys, an ellipse is just a special case circle. That's all it is. All right, so I'm going to end the video here. Stay tuned, and we'll come back and do examples 2 and 4 in the next video.